Welcome to a lesson with Dr. Powell. Let's compute the derivative of this function using the limit definition of a derivative. Okay, we're just taking the limit of a difference quotient, and one of the points will have an x in it. We're going to use the a strategy. So the other point is x and a. So here I have 1 over x plus 3. Here I have 1 over a plus 3. Take rise over run. So 1 over a plus 3 minus 1 over x plus 3 all over a minus x, taking a limit as a approaches x. All right, so in this computation, remember that a is the variable in the computation, variable of the limit. It's what's changing. It's what's getting close to something else fixed, something else constant. X is a constant here in this expression as we're thinking about limits and domains and stuff like that. X is the constant, a is the variable. We can't set a equal to x here because that's not in the domain of this expression. So we're going to think equivalent fractions. Multiply top and bottom by something. I want to multiply by something such that the denominators will go away when we distribute. Look at those two denominators. What if I just put them up here like this? So this whole bit will distribute to each part, to here, and when it does, we'll get some nice cancellation. To the first term, all right, a plus 3 and a plus 3 will cancel, but we'll be left with an x plus 3. When this comes to the second bit right here, what's going to be left? The x plus 3's will cancel, be left with an a plus 3. And this will be over a minus x times a plus 3 x plus 3. Be nice if like an a minus x would cancel with the top, and indeed it will. Notice, see this negative distributes to both parts. Distributing to the 3, it becomes a negative 3. With that 3, will go away. We'll be left with x minus a. Wait a minute. X minus a, if we factor a negative out of that and switch the order, it actually is negative a minus x, and you can check that. When this negative comes in, you get a negative a. Hey, negative a. The negative comes to this x because a positive x. Hey, positive x. It is the same as what we're left with. So knowing that, notice that we get some nice cancellation. You can think of this as negative 1 times a minus x. The same minus x will cancel with that one. We'll be left with a negative 1 on the top over a plus 3, x plus 3. We're taking a limit as a approaches x. So that's going to be equal to negative 1 over, and in this case, now, since the domain issue is gone, we can throw in x for a here. So x plus 3, or just simply negative 1 over quantity x plus 3 squared. And we just computed the derivative function of f of x using the limit definition of a derivative. Thanks for watching.